Hi, I'm Nathan Tracy from TE Connectivity, and I'm speaking to you today as president of the OIF. And when I think about the data centers of the future, where machine learning and artificial intelligence are becoming the new key um, requirements that have to be met and delivered, it's just a mind-boggling shift in set of requirements in terms of the bandwidth that's going to be required, in terms of the density, the bandwidth density that's going to be required. And those two things are going to absolutely drive the power consumption and the thermal management that's resultant in those data centers. And so the OIF, as a global industry standards organization, is forward thinking about those challenges and what efforts within the OIF are going to be required in order to enable these next generation of hyperscale data centers. Some of the key things that we're working on are the 200 gigabit per second electrical interface developments that we're doing. And here we're looking at developing several different electrical interfaces, each one optimized according to the reach that has to be delivered at the lowest possible power. So we don't want to have a one size fits all that potentially wastes energy, but we want to optimize for the lowest possible power. The other thing that we're doing is we're working on linear optics. So linear optics are where we remove the retimer from the optical modules, and it provides a significant savings on power consumption and also cost as well. And what we're doing there is developing the 112 gig linear optics specification. And it's truly a very challenging effort. Now that's a more near-term effort. The other thing that we have kicked off is the energy efficient interfaces project. So this is a more holistic view of all the electro-optical link requirements that are going to be required in that AI data center. So we're looking at, what are the fabric data rates and latencies that are going to be required directly at the GPU and the CPU interface. So here we might be talking like PCIe or CXL bandwidths, but then also the backend fabric where 200 gigabit is going to be a critical building block to deliver that next generation bandwidth and bandwidth density. And so we're looking at all of those requirements. It's a multitude of different links with different requirements. Each are going to drive different project activities in the OIF. And we're moving very quickly on this because the industry can't really afford to wait. And so we're building through this framework project. The result will be a white paper. We'll be able to bring that to market, and immediately we'll also kick off the specific projects based on the prioritization that we determine to meet those, whether it's the GPU interface at a PCIe rate, or whether it's the backend fabric where 800 gig or 1.6T are going to be the data rates. Additionally, we're continuing the work in the OIF on CMIS, which is Common Management Interface Specification. And as we get to these higher performing, smarter modules, this is going to be critical. It enables all of the host equipment to have a common language, to talk to all of those modules and control the modules, optimize those smarter modules that are going to be coming to market and control those. And then, of course, there's the OIF's 400ZR, 800ZR, 1.6 terabit ZR work that is ongoing. And this is also going to be very critical to these next generation data centers where increasingly we see the bandwidth requirements driving a need to bring coherent optics inside the building. And so we're building that capability, working with all of the OIF members and writing these specifications that will create the true interop that the industry needs for the scope and the scale of these next generation AI data centers. So come and join us at the OIF.